Hello, welcome to Ekidel. We are trained future civil and structural engineer. My name is Justice Moka and I am your instructor. Today, I'll be showing you bridge design. So basically, looking at this right now, you will see that this is a pedestrian, or basically you can call it a foot over bridge design. So basically, this is a live project and this project is sited in Kigali. So looking at this right now, you can see that we have already done the modeling for this 15 meters footbridge design. And now I'll be showing you how to add the load. Basically, we are already done with this bridge design and all that. So we are about performing the structural detailing for this. So this just brought to our notice that we should use this project right now to now show you how to how to add loads to your bridge. Although we will still perform a full structural design for this bridge, but I think that should be either next week. So for you not to miss that video, I would say that if you have not click on the subscribe button, you can just subscribe to our channel Ekidel so that you don't miss this amazing video. Okay, so right now, before I'll begin to add the load on this footbridge design, I will try first of all to tell you what you are meant to consider when you're performing your bridge design. When I mean bridge design, bridge basically has different types. So I am trying to just classify this bridge right now based on the scope of this project. So when I mean bridge design, whenever you hear me say bridge design, I am simply saying a pedestrian bridge or a foot over bridge. Okay, so right now when you are designing for for a footbridge design, there are some things you are meant to consider, and those things are the loading. Now I will tell you that designing a building is more simpler than you designing a bridge. All right, so right now the loads that you are meant to consider when you are designing for a bridge is one is human traffic load. Now you must consider human traffic load for when you are designing for a pedestrian bridge design or for a foot over bridge design. Okay, in these recent months throughout this year, we will be doing bridge design a lot because we have got some projects in Kigali, and there are several pedestrian bridge that we are meant to design, although we will be sharing those designs with you. So right now, as I was saying, there are some loads that you are meant to consider, and before I start, I will say that the code I am using for this design is Eurocode. So right now, once you're done with your modeling, then it is now time for you to load your structure, which is your bridge. The first thing you are meant to consider is to consider the human traffic load. This is in the sense of pedestrian bridge. If it is for a vehicular bridge, you are meant to consider human traffic load and also consider vehicle loads, majorly vehicle loads for a vehicular bridge. But right now for this is just a foot over bridge, which simply means pedestrian bridge. So once you consider your human traffic load, the next thing again that you are meant to factor is the self-weight of the bridge and its finishes. So when I mean this self-weight of the bridge and its finishes, you know that there are some bridge or some flyovers or some bridge that you will see, and then they might have some kind of finishings, like they might have billboards and all that attached to the bridge just for adverts. Now, although that is more common in Africa and most of European countries, where you will see billboard attached to bridges just to show adverts, and that's like a way of also generating revenue for the state or for the country. Okay, so you have to consider the self-weight of the bridge and also its finishings. Okay, now once you consider that, then the next thing you will consider for the loading is the wind load. Now, no matter what you are doing, you must consider wind load for a bridge. Knowing that when I taught you guys wind load on building, I taught you guys that that unless your building is up to 10 meters high, you must not add a wind load. But for bridges, any bridge you are designing for, you must do what? You must add wind load to that bridge. Be it footbridge or vehicular bridge, you must add a wind load to that bridge. So wind load is very, very essential because bridges are prone to wind effects. Okay, so right now the next thing again you consider is earthquake load. Although the earthquake load is not applicable everywhere in the country, but if your country experiences earthquake, then you have to apply earthquake load. So earthquake load, or you can call it seismic design for the bridge, is basically if your country experiences earthquake. Okay, but for countries like Africa, you can just ignore earthquake, except you are living in basically northern Uganda. Then you can begin to apply earthquake because northern Uganda experiences slight earthquake. Okay, then the next thing again you consider is snow load. Snow load is not really compulsory except your country experiences snow, like countries like Americans, like US, and Luxembourg, and most Germany, and most of the countries that experiences snow. But if your country doesn't experience snow, like countries in Africa, you can ignore snow load when you are designing for your bridge. Okay, now for your bridge, you don't consider rain load. We don't consider it for bridges. Now the next thing right now you will consider for your loading is dynamic water pressure. No, you have to consider dynamic water pressure, but that is only if the bridge is crossing water bodies. Understand? If the bridge is crossing water bodies, then you have to consider dynamic water pressure. Now when it comes to footbridge or footover bridge or pedestrian bridge can be sited anywhere. It can be sited anywhere. It can be sited across let me say across a small stream. It can be sited across a highway, just to allow to be able to allow pedestrian to like cross over to the other side of the highway. Okay, so unless your footbridge or footover bridge is in contact or is passing through a waterway, then or crossing water body, then you will have to consider dynamic water pressure. Now the next thing that you must consider, which is very, very important, is thermal action. Now thermal action simply means temperature load. Knowing that when it comes to bridge is basically exposed daily, seasonal, and annually to environmental thermal effects. You understand? So you must include thermal action, which is temperature load, on your bridge. Okay, now once you apply temperature load, the last thing but not the least that you are meant to consider for loading is possible accidental actions from impact. Knowing that, let me say that if this bridge right now if this area was a highway, like if this bridge was crossing over a highway, there is every tendency that a car might fail brake one day and hit this support, hit this bridge embankment. Now if you don't consider possible accidental action for the design of this embankment, then what happens is that there will be a failure for this embankment, and when this embankment fails, invariably your bridge has failed, because what is holding this truss is this embankment. Okay, so you must consider possible accidental actions from impact. Now this particular load comes with Eurocode. It is basically not on BS code before, but when this code came into existence, Eurocode, they consider possible accidental actions from impact. Now this load is also applied for buildings. When you are building your building, or let me say when you are designing for a building that is being sited near the highway, you must also apply possible accidental actions from impact. Okay, so there are various ways where you can apply all this load. Now I have mentioned over 7 or 8 loads for bridges. Now I'll just quickly summarize the main ones that you are meant to consider, which are very, very important. One is the human traffic load. When it comes to pedestrian bridge, you must consider human traffic load. Then you must also consider the self weight of the bridge and its finishes. And then you must also consider wind load. Wind load is very, very important for bridge. And then after wind load, you must also consider thermal actions. Thermal actions, which is temperature loading, and then the possible accidental impacts, actions from impact, from vehicle impact or another. Okay. Then the other one is dynamic water pressure. That is if only your bridge is crossing water bodies. That's when you're going to apply that to your pedestrian or foot-over bridge design. Okay. So right now I have told you the loadings that you are meant to consider. Now, when you are designing for a pedestrian bridge or for a foot-over bridge, they are still the same. The load that you are meant to consider, which is the life load or imposed load, is 5.0 kilonewton per meter square. So that is a load you are meant to consider, because basically a pedestrian bridge or a foot-over bridge is basically for humans to is basically for human use and not for vehicles. Although people that ride bicycles and all that can still use it. Okay, so because of that, the load that we use, and based due to the traffic of human that will be trafficking on that pedestrian bridge, so the load that is very, very good to use is 5.0 kilonewton per meter as per Eurocode, as per Eurocode 1 section 5. Okay, so you are meant to use imposed load of 5.0 kilonewton per meter square. Okay, so right now I'll be loading this bridge right now. So to load this bridge right now, I will have to come to this bridge girders here, and I'll begin to apply my load now based on this bridge here. So right now I'll have to click on this place now. Right click here and do what here and say edit loads here. Now once I edit load now, I will now have to wait for it to now show the editing load dialog box. Now I am using Prota 2022, which is 6.0392 and all that. So although most of the times most people that has the software might not be able to load it, I don't know if maybe you are, I don't know how you get your own. Okay, so right now you will be able to see this right now. Now once you see this now, you can see that we have several loads here. We have a point load, we have full uniform load, we have partial and all that consider load. Now I will have to use what? Uniformly load. Okay, so I'll click on uniformly load right now, and then I will have to specify my load magnitude here. So I'll come here right now and put 5.0 kilonewton per meter, and then I'll come here right now and then click on this member here, and the load here will be applied. As I can see there, 5.0, and I'll click again on all other ones here, click here and click here and click here. Okay, so right now I have now applied load on all this. I'll now come here and then click on what? OK here. Okay, so once I say OK now, I have just, if you look at this now and look at this thing, that is, you can see that this now has a line load of P equals to 5.0 kilonewton per meter. Okay, and this other one here doesn't have any load yet. So right now I'll quickly come here, right click here and then copy. Since I've already done the load already, I can quickly come here again right now, click here and then edit. Instead of the copy, let me just repeat so that you can be able to grab it very well. So I'll come again right now and click here, and then come here and zoom in here a bit, then come here and click my load here, and then come again here and add my load value as 5, and then come again here and click here right now, click apply the load here and apply again, and then come here and click on what? OK here. Okay, so right now we have applied the load on this right now. So right now, for me to be able to copy the load now, I'll have to go back to story 1 and make story 1 active. And since this one, this other one here, we have already applied load on this, I'll really click on this right now. I click here and I'll say, and I'll come here. There will be a copy option for you to copy loads. Okay, so let me just see. Okay, it's not showing here. Let me just apply the load generally here. So I'll come here again and apply the load here. So I'll apply the load right now on all this. Click again and apply again. Come here, say this, and then come here, apply 5 here, and then click there, click here, and click here. Okay, so I'll apply it now for all this one here. I'll apply it now for all this, and I'll come again right now on this. Click on this right now. Sorry, not that. Click on this right now. Right click here, and then come here and say what? Edit loads. And I'll just repeat what I've just done so far right now. Click here, and then put my value of load here, 5, and I'll come here, apply it here, apply it here, apply it here, and apply it here. Okay, that's fine. Okay, and I'll come here right now. That's okay. And I'll come here and then click here, okay here. Okay. Okay, so we have applied on this. So remaining these two right now. Click here again right now. Right click here, and then click here, and then go again by hold on for it to load. Now once it loads just now, I will now go ahead now and then sorry, not this other one. Right click and then say load. Yeah, that's fine. And then click on the load, click on this right now, apply 5, and then come here and click this, click this, click this, click this. Okay, and then come here and say okay, and then come here again, click on this, right click here, and I'll say what? Edit loads. Okay, this is the last one. Zoom in here and then put in my load here, 5, and I'll click on this, click on this, click on this, and click on this final, and I'll sorry, let me see, and this final, sorry, remaining one, left it 1, put my 5 here, and I'll come here now and then click and I'll apply the load here. Okay, that's fine. So I'll now come here and then click on what? Okay here. Okay, okay, that's fine. So right now I'll go again, and then so once we have applied our load here, you can see that we have applied all the load under this bridge getter here. Now we also need to apply the load again on this other this thing here. So on these other members here that is carrying these other members here. So right now, but the load value here will be different. So I'll come here right now, right click here, and then do what? Here, say here, edit what? Edit loads here, and I'll come again now, and then now you can see that the both reaction is just 0.4, 0.4. This value of reaction is due to based on the self weight of that member. So right now, come here and then click on what? Uniformly distributed load here, full, and then come here. Now this value now will be 2.5, not 5.0 again, 2.5, and I'll come here again right now, then click on this right now. Now you can now see that these two reaction now has now increased to 4.1, because right now we now have the self weight load and also the load that we have imposed on that building. Okay, on this member. I'll now come here and then click on what? Okay. So right now I can now go ahead and copy this particular one right now. Right click here and say copy load. Now once I've copied it load, I'll say yes, okay. I'll now come here right now, click on this, and then click on this, and click on this, okay, and then come again here, and then click on this again, okay, and then come to the last one here. We have the last one here, and click on this here, and we also have a last one around this area here, which we are meant to add. Okay, we have already added this here, yes. So I apply this one to the last one here, okay. Then right click here and then say what? Paste load. Okay, I'll paste it now, and then it has now been pasted. So we have just loaded that just now. Now you can also see that we added a wind brace in here. So right now we have added, I say that we are going to add human load and all that. So we have added the human load and the self weight. So the next load now, which is to add what? Wind load. Okay, so wind load right now, to add a wind load on your structure, you have to go to analysis here. Okay, sorry, loading here, and then from the loading here, you will now click on what? Wind and story load. Okay, then wait for it to now open up. Okay, so once it comes up now, the next thing to do right now is to now click on what? Here, wind load calculator here. Okay, now once you click on that just now, sorry for that. Okay, sorry, before we do this, we are meant to go and define our wind load case first. So right now I'll just say cancel here, and then cancel again right now, and then let's go and define for our wind load case before we can apply the wind load value or the wind speed value on this bridge. Okay, So for us now to now specify the wind load case, we will have to go to this load case and combination here and apply wind load, okay? Because what I've just applied here is the load combination and also temperature load. As you can see that this T here simply means thermal load or temperature load. So right now let's not go and define for the wind load case, and wind load case is basically W. So right now I can see that there is no W here specified, WX or WY or WZ. So right now I'll now come here right now and specify my horizontal load here. So on this place now, I'll have to come here and apply what? Wind load here. So once I click on this now right now, wind loading here, I'll now come here right now and then click on what? Okay. By doing that right now, you can now see that it has not applied W. So W basically is for wind. It is for wind effects. WX, WY, you can see that they are for wind effects. So right now, I'll now come here and then click on what? Okay. Okay. So once I click on OK now, I'll say yes, okay it here. So when I click on OK now, I will now go ahead and I'll wait for it to finish up, and then we'll now go and apply our wind speed, okay? I'll say yes, okay it, and then now okay. So right now, let's now go and apply our wind load. So I'll come here right now and then click on this right now, and then come here and then click on wind load calculator here. So on that now, you will now see your wind load calculator dialog box now will now appear here. Now once it appears, I've always explained this a lot, although that is I've explained how to apply wind load, although that is for buildings, okay? So for bridges, although not really different, but just a slight difference, okay? So right now for like bridges, when you're applying wind load for like bridges, the first thing we'll do right now on this place is to do what? Specify our wind speed, okay? So basically wind speed is gotten from the weather scientist of the particular of that region where that bridge is meant to be sited. So you have to get the average wind speed that have occurred or that occurs around the place where you're meant to site your bridge, okay? So right now in this for this project, which is in Ekidel, Rwanda, the wind speed on that area is 15 meter per second, okay? So right now, once I've applied that now, I will now come here and then this place that says minimum wind pressure, leave it as default. I have said much about all this in my last video. So if maybe you have not known how to apply all this, I'll say that you should go and watch all my videos on wind speed, okay? Now I'll come here right now, then come here and click on this now. Once I click on this now come here right now and then apply what, and then click on this and apply to steel, because we are designing for a steel structure, okay? So I'll come here right now and then apply for steel, okay, and not for reinforced concrete, okay? So on this now, I'll now come here and choose my terrain categories, okay? So I'll come here and click on this right now. I have said much about this before, so if maybe you don't know how to select all this, I will say that you should watch my videos on wind load, okay? So right now I'll just quickly come here right now and then click on this and choose this and then say okay. Okay, so there is a reason why I chose that. So I'll say that you should go and watch most of my videos so that you can know what I did, okay? So I'll come here just now again and then click on here and then say what, apply here, okay? And then come here and then click on what, okay. Okay, so right now the load now have now been applied to this structure, okay? So this structure right now has a wind load applied to it, okay? So right now, as you can see, we have applied human traffic load, we have applied the self weight of the bridge and finishes load, we have also applied the wind load, and then what is left now? There is no earthquake on this place, Rwanda. There is no also snow load, so we are going to ignore snow load. We are also going to ignore dynamic water pressure, because this pedestrian bridge is basically not crossing through the water bodies, okay? So the next thing right now is now apply thermal actions, and once I apply thermal actions, I will now come and apply possible actions for what, from impact, okay? So that is the two loads that are left for us to apply. Now I'll say that before I continue, I'll say that if you have not clicked on the subscribe button, and if you have not turned on your video notification, I'll say you should do that just now so that you don't miss amazing videos that we will be performing here on Ekidel. Basically, Ekidel is a place where we train future civil and structural engineers and grind them up to make sure that they achieve the best of their career. Okay, so right now, what is left now is thermal actions and then the possible actions, the possible accidental actions on from impact. Now, the other one, which is the thermal actions, is being applied generally on the structure. Okay. Now, the other one, which is the possible accidental actions from impact, is being applied on these embankments. Okay. So right now, let's now go and apply the thermal actions, which is temperature, load. Okay. Now, for you to apply thermal or temperature load on your bridge, the first thing I'll do right now is to come here and then click on this place that says temperature temperature difference data. So I'll click here right now and then come here and then apply what? And then come here and apply 8 degrees, okay, 8 centigrade. So I'll come here right now and then click on what? Okay here. So with this right now, I have applied temperature load on this bridge. So the next thing now is now apply possible accidental actions from impact, which is going to apply on these embankments here, on these 2 embankments here and here. Okay, so right now I'll be applying these possible accidental actions on my next video. So for you not to miss that video, I'll say that you should just click on the subscribe button and also stay tuned to Ekidel videos and also all our uploads so that you don't miss amazing videos. Now, there is something I want to explain to you guys, that on this month of September, we are given a 50% discount on our online mentorship training. Now, our Ekidel online mentorship training is it is at its top notch. So I'll say that you should not miss this this opportunity where we are given 50% discount, because after this September it will come back to its normal price, and most people have been complaining that our training is expensive. Although the reason why it is expensive is because we take our time to train you and teach you, and if you also check out the course and if you can check the training syllabus of what you are going to learn by the end of the 6 weeks of our training with you, you will see that you are going to gain a lot. So it is not really we have had visible testimonies all over the world. We have trained people from all over the world. So I'll say that you should make yourself available, enroll for that, and to get that, to also apply for that, for you to be able to achieve that percentage, you can check the link down below and then enroll for that. Okay, and once you enroll for that, and then we will just kickstart with you and then train you. Our training is basically live screen. We will train you live screen based on your time zone and all that. Okay, so thank you so much and God bless you. We'll love you, and then goodbye for now, and then see you again next week for this bridge design. Okay, so you can see that I have explained a lot on the type of load you are meant to apply on your structure, and you have seen how I have applied it, which I applied human traffic load, I applied for the self-weight and finishes, I applied for the wind load. I didn't apply for earthquake because because there's no earthquake on this region where this bridge is sited, which is Ekidel. There is no also snow load there, and this bridge is also not crossing water, so I did not apply the dynamic water pressure. Now I didn't also apply I applied thermal actions, and I said in my next video I'll be showing you how to apply possible accidental actions from impact in case anything hits these 2 embankments. It will not have an issue of collapse or not that. Okay, so it will be able to withstand that impact from that vehicle or from any obstacle. So you can now see now in my next video also I will show you how to model this bridge, and also how to choose your member, and also how to customize your own truss, because when it comes to bridge design, you must there are some designs, or there are some projects that you tend to customize your own truss by yourself. Okay, so right now on my next video too, why I apply the that possible actions from accidents, I will also show you how to model this kind of bridge, although it will take time, but we will just begin from that. Okay, so thank you so much and God bless you. We'll love you, and then see you again next time, this time next week. Goodbye for now. Bye.